Good morning. Now, in today's class, we will discuss some programs to demonstrate types of constructors. Types of invoking the constructors are as follows: one, implicit call, explicit call, and using assignment operator. We will see programs to demonstrate these three types of invoking the constructors. Let us see the program one now. Okay. Now, let us see a class like box. Right? Let there be two private members, length and breadth. Right? Box is the default constructor in the public section, and we have the box int x, int y as the parameterized constructor. And here is one more constructor, the box, which is the copy constructor, box and obj. I have just declared it here. I will define outside. Next, the display function to display the values of length and breadth. Now, definition of the box copy constructor, sorry, box default constructor here outside the class using scope resolution, length is 0, breadth is 0. Then the definition of the parameterized constructor, all these things you know already. Length is x and breadth is y. Here is the definition of the copy constructor, box uh, and within parenthesis box ampersand obj. So length and breadth are initialized to the length and breadth of that obj. So length is equal to obj dot length and breadth is equal to obj dot breadth. That is, obj is a reference to the already existing object of the class box. So its length is assigned to the length of the newly created object. Similarly, the breadth of the existing object is assigned to the breadth of the newly created object. That is the definition of the copy constructor. Now we will have the main here. We create the first object which uses the default constructor anyway, b1. This b2 object uses the parameterized constructor, and b3 also uses the parameterized constructor with the different values of the length and breadth. Now you know box b4, object b4 is called in this way where we pass existing object b2 as its parameter. That means this calls the copy constructor. Correct? Now we see how to write the explicit call of the constructor, especially parameterized constructor, and implicit call, and of course with the other third type. Now this one, in this way, if you write box b2, look here, box b2 100, 35, this is called implicit call of the constructor, because we write here just after writing the class name and the required object name, there only we pass the arguments within the parenthesis as the arguments. But in explicit call, if I am writing the same explicit call to create the same object, I would have written like box b2 is equal to once again box and within the parenthesis these values. So this becomes explicit call, right? Explicit call. So you got the difference now. Only the difference in writing the object creation and thus calling the constructors. So when you write after writing the equal to sign, then once again the name of the constructor and then the arguments, that becomes it is explicit. We are explicitly writing once again the name of the constructor here. Right? Whereas this one is implicit call. Directly we are writing. It is implicit. That is all the difference between explicit invocation and implicit invocation. I think you are able to write that. Now, the third type, of course, this one is also implicit call only. The third type, when while using the assignment operator, while declaring an object. So this one is possible when we are having especially only one data member in a class. When we are having only one data member in a class. but this class has two data members, right? How to do it? Even for that, it can be done. But to demonstrate that, I will create a new class. Okay, I will create a new class. Suppose the class, I will create a class with only one data member. Right? Suppose class circle. So usually a circle has only one data member, the radius. Correct? Int radius or simply r. Right? In public, we have the constructors. Circle. This is the default constructor directly defined, where radius is equal to suppose 0. This is a trivial case. And the next, I will have a parameterized constructor. Right? No need. Just you can have any one of the constructors. Right? But to have some values, actual values of the radius, we must have the parameterized constructor. Int a. A becomes the radius when you pass from the main. Then r is equal to a assignment, and that's it. The definition of the parameterized constructor is over. Now we'll close the class, right? And void main. Create the object circle. Suppose C1. This is the first object which calls the default constructor, right? And I will call another object which is C2, which uses the parameterized constructor. Suppose the radius is 5. I will pass that. Then I must have the display here. I will add the display later. Right? Then I will create another object like C3. Observe this. By directly assigning the value, C3 suppose is equal to 10. Look at that. This type of invoking the constructor is called using assignment operator. Using assignment operator at the time of creating the object. So directly I have given a value to the object only. How that is possible? It is possible that the value assigned will be directly assigned to the only one data member. This class circle has only one data member, correct? That is why the value directly assigned goes to the only one. So in this case also we are doing the same thing. So this is a different variety of calling the constructors. That's it. So in this case, there is a possibility that we can have one more in case the class contains two or more data members. I will write this. So display using C1, right? Then C2 dot display. I yet have to divide this, and C3 dot display to end the program. Here I will add the display function here. Void display cout radius of the circle is equal to, right, r, right? That's it. I'll save this. Demo 3. Look at that. I will execute the program. Now look at the output of this. So there's some other output. I will clear that. So when you execute this, the output is for first display C1. How much C1? It calls the default. So the radius is 0, first value. Second one, I am passing 5. So the radius becomes 5. And the third one for C3 dot display, the radius becomes 10. You can observe this. See, first one 0, second one 5, and the third one circle is equal to radius of the circle is 10. That uses the third way of calling the or invoking the constructor. That means using the assignment operator. Is it clear? So by this program, you understood the three different ways of calling the constructors using the assignment operator, the third type, This is all example of implicit calling. In explicit, you should write like, once again, circle. In this way, this becomes explicit call. This, the first C1 is using the implicit call, C2 explicit, and the C3 using the assignment operator. I hope this is clear too. Next, we will discuss a concept of constructor overloading. Constructor overloading. I look at the same program. I will open the same program, right? I will just open the same program which you have just now seen, demo 3. Right? Look at that. In this circle class, we are having how many constructors? There are 2 constructors. First one is the default constructor, right? This is the default constructor. And the second one is the parameterized constructor. So in this program, we are having 2 constructors. So is it possible to have 2 constructors? Yes, it is possible. We have defined it. We have written programs. That means already we have overloaded constructors. The concept of overloading already you have seen in the previous chapter, chapter 8. Do you remember that? What do you mean by function overloading? Function overloading is having 2 or more functions with the same name but different number of arguments or types of arguments in the functions. So if you have the same function name with the different uh, definitions using different arguments or different types of arguments, then it becomes function overloading. So what are constructors? You know that constructors are also basically functions, member functions inside the class. So when you have 2 or more constructors, it is nothing but overloading of the functions only. That means overloading of the constructors. So already we have studied this. So if you understand that overloading of constructors is same as overloading of normal member functions in the class. So it is good as having 2 or more functions with the same name, is it not? Yes. That is why we say when you define 2 or more constructors, one default, one parameterized, or one more parameterized, one more copy constructor, that means already you have done the constructor overloading. So I think to explain using a program, you need not have to write a separate program. Even the same program of the circle or the previous box, which all have 2 or more constructors, that is enough to understand overloading of constructors. I hope you have understood constructor overloading, correct? Right. Then there are some points to consider, right, in uh, invoking the constructors. In the third type, we have seen that direct assignment operator. Here, some points to remember. This method of using the assignment operator is only applicable to the constructors that have exactly one parameter or one data member in the class. Right? But is it possible to make use of the assignment operator when we have more than one data member? Yes, it is also possible. Right? Like when you define a constructor, I will show you like this. Observe this. Here I will define one more constructor for a program. Right? I will close for the moment. Uh, I'll open another program. This one. Look at the program box. Here there are 2 members, right? There are 2 members. Now I will define a constructor like this. Observe a constructor which uses only one data member and one argument. Box int, suppose length. First one is length, len, right? Only one. Right? I will define the first data member is in this case length and the second one is breadth. Now look at this. Here I will define length is equal to len, and the other one breadth is equal to directly some value I will be giving, right? 4. Correct. I will close this. Look at the definition of this constructor. It is a constructor once again parameterized constructor, but though there are two data members in this class, length and breadth, I have given only one parameter, correct? That means the parameter value length should be assigned to the first length data member, and the other data member breadth is directly assigned with the constant value. So in the main section, if you create an object, I will create an object here like box b5, look at that, b5, and passing only one, the length only I will pass, breadth already I have assigned there, the length I will pass like 10, right? Length I will pass like 10. I don't pass any second argument here, right? Look at that, and I will call b5 dot display, b5 dot display. Now let us see the output. Let us see the output. I will save this, execute. There is no error, see. Can you see the last line? Box length is equal to 10, width is equal to 4. The question is, from where are you getting width 4? It is because directly you have assigned, see. So, see, in this case, I am passing only one argument, right, which is nothing but the length of that, and the width I have directly assigned there in the definition of this constructor, right, here. Show you, right. In this case, see, only one direct. Now I will change the way it is used while creating that. I will just change it to 10 like this. Are you getting this? The way I used to invoke a constructor using the third method. When you create an object, directly use the assignment operator and only one value, direct value given there. Right? I will see. Can you see that? Can you see? Box length is equal to 10. Still, I will change the value. Right? I will change the value here in the main. Instead of 10, let me pass now something like 7. Right? Save this. I'm using the third way of invoking the constructor. See, the length becomes 7 and the width is 4, which directly comes from the value. Are you getting this? So that means, though we say that when we use the third way of calling the constructor, right? This is not explicit, not implicit. It is using equal to sign operator, assignment operator. We said that when there is only one data member, especially we use this. But in this case, the box class has two data members. Even then, we are using this way. The constructor is called using the assignment operator with the direct one value 7 given, provided we define the constructor in this way. The only one parameter is taken here. The value 7 comes and it is assigned to the first data member, and the second data member breadth is assigned with a value which directly we give in the definition of the constructor. I hope you have understood this, the variety. So that point I will make it clear once again. So especially this method is applicable to the constructors that can have exactly one parameter. So in the class, if the class contains at least one parameterized constructor, then the necessary arguments have to be passed to the constructor in the declaration itself. I'll repeat the point. If a class contains at least one parameterized constructor, then it is necessary uh, to pass the arguments to the constructor in the declaration itself. In the declaration itself, we have to pass. That is what I have done here, right? Directly by passing the arguments is equal to 7, right? Like this. And one more point, if the user does not want to pass arguments, then the default constructor must be created in the class. This is a very clear point. See, in this case, look at the object b1. This does not use any arguments. That means it uses the default parameter or zero argument constructor, the default constructor, I mean. Provided if you have not defined the default constructor here, see, if you have not given the default constructor, suppose I will block this, right? Then it is not possible to, I will show that it is not possible to run this program. See, there are errors coming because there is no default constructor declared in this case. That means in the program, if you have a plan of creating objects which use parameterized constructor, then it is a must to declare even and define a default constructor so that the program runs in case you are creating objects which use default constructor, right? Okay. Now we will go to another concept in this chapter which are called destructors. So as you know, constructors are special member functions of a class. Similarly, a destructor is also a special member function of a class, right? I will show you that. Destructor is a special member function of a class. How to create a destructor? So what is the purpose of a destructor? Destructor eh, is used to clear the object when the program gets terminated, or when there is no need of the object in the program. When you exit from a program, the the automatic deinitialization of the object takes place by using a special member function called the destructor. So a destructor is a special member function which is used to deinitialize the objects of a class. Now we will um, create a destructor for this. I will show the same program, the class circle. How to define or declare a destructor? I will define a destructor here. The destructor name is also same as that of the class name, but it precedes with a tilde symbol. What is the class name? Circle, right? CLE, circle. Right? So that is how I will define destructor. So destructor name is same as that of the class, and also it follows a tilde symbol. Here within a destructor, we need not have to write any statements because no initialization is done. The only thing is we can write a statement simply to uh, display some message like this and nothing else. So what happens? You know that when you execute this program, whenever you create objects, the constructor will be called automatically. Similarly, when you go out of the program, right, automatically the destructor will be called. I will show you how is that. Right? Destructor. It should be this. It should be defined in the public section. Yes, circle, class circle. 1 minute. Yes. One minute. Statement. I will define the destructor within uh, outside the class. Right. 1 minute. I will define the destructor outside the class. Actually, it should run now. Right. If it is not run, I will declare the destructor here. Yes. Reduce to the circle. Yes. Can see the destructor called. Can you see the output here? Three times the destructor executed, because after the program gets terminated, there are three objects, C1, C2, and C3. All these three objects are destroyed when we take the exit. That is why it displays destructor. I destructor called, right? Destructor called, so that we will understand, right? Calling of the destructor. I will show the output again. See, when you terminate, after the output is over, when you terminate from the program, then it is executed. Just to show that it is executed, I will be writing a statement like a destructor called. Otherwise, there is no need to write a destructor. So a destructor is a special member function which is used to deallocate. And similar to the constructor, observe the points. Destructor has the same name as that of its class. The first character must be the tilde symbol. Destructors do not have a return value. Destructors can never return value. Right? They are only to destroy or deallocate the memory occupied by the objects. They take no arguments. Therefore, overloading of destructors is not possible. That means we can write only one destructor for a class. The most common use of destructors is to deallocate the memory, as I told, which is allocated for the object by the constructor. So, destructor is also defined in the public section, similar to the constructor. So there we end this chapter. Now, before ending, I will show you one more program which is given there in the textbook. It is regarding using of a copy constructor to find the factorial of a number. To find the factorial, a copy constructor is used. I'll read the program. Look at the program here. Class copy into where public int copy int t. It is a parameterized constructor. Copy and obj is a copy constructor using which we copy the value of an existing object of the class to another object. Int fact, here we find the factorial of the given number. Int f I, you know how to find out the factorial. F is 1, for I is 1, I less than var is the data member, only one data member. I plus plus, f is equal to f star I, return f. Now in the main, look at that, enter a number int n, c in n, copy, create the first object obj1 by passing the given number. Suppose if you enter 5 to find out the 5 factorial, pass n, the n will be passed to the only one data member, which is var. In this case, the data member is var. So this will find out the factorial of later. Object 2 is object 1 using the copy. This uses the copy constructor, right? This is just to demonstrate the copy constructor, nothing else. We have another function here to find out the factorial. Now, using the two objects, I will be calling the same factorial function, fact function. So, first object 1 I will call. That is why whatever the value you pass, it will find out its factorial. And since object 2 is a copy of object 1, object 2 dot fact also displays the same result of the first. Right? I will execute the program. There is a warning because it's inline function. Neglect that. It is not a problem. Now see, destructor, enter a number. I will enter 5, right? So factorial using object 1 is 120. It is copied to object 2. That is why it is also displaying 120. Now I'll run the program again, right? Using enter a number 4. Factorial using object 1 is 24. Factorial of 4 using object 2 is also 24 because object 1 is copied to object 2. Correct? So that is a program for this. I hope you have understood constructors, types of constructors, and invoking methods of constructors, some examples of all the varieties of constructors, then overloading of constructors, and also the destructor at the end of this chapter. Right? It's a very important chapter as far as scoring in exams is concerned. Thank you. Just to go through the program, copy constructor, and one more, the factorial member function, just to find out the factorial of a number. Thank you.